welcome to the second panel on of the eFlight Expo Forum we have this year here at AERO. We had the first one this morning on eVTOLs. Now we're going to speak about the most important thing on electric aircraft, which is the electric propulsion system and the energy source. And we mixed a little bit because in former years we just had all people just talking about motors and some other people talking, some other forums on just energy source. This time we mix it all a little bit. We have some people talking about energy source. We have the university, the DLR Research Institute, which is very fresh. So it will be some news for you as well, that we have a special institute now for this in Germany. And yes, just as a general information for you all, when you're interested in electric aviation, electric flying, together with the AERO Fair, we released this guide on electric flying here on the show. There is, in the middle of the magazine, there is a map of the show, and you find all the halls, and in the halls, which companies, which associations are in the halls, and can tell you information about electric flying. With this, I think, because the time is, you see I have a lot of speakers, and the time is short, so I hand over to Phillip Scheffel from the company APUS, who is working on aircraft with electric propulsion. You can see their first prototype in the A7 hall. And yeah, Phillip, it's yours. Tell us what you're doing.
Yeah, welcome here on the fair. Nice to see there are some people around here. Yeah, APUS Group is. Do you see something already? No. I see it, but you don't see it. Come around. Yeah, then maybe first to my person. I'm Phillip Scheffel, the CEO of APUS Group. Glider pilot since many years, and so passion for energy efficiency. I was working for 10 years at Stemme, an aircraft producer close to Berlin. And since 2014, we started an own aviation engineering design office. And since that time, we are developing for OEMs several systems, structures, undercarriage, whatever. Yeah, since a few years, 3 or 4 years, the focus is more and more on powertrain systems in aviation, in the third revolution, as we call it, in aviation. So also design office needs to focus on that. And that's what we are doing here. Yeah, we are, as I said, in the east of Berlin. Now we have it. Yeah, okay. So, yeah, we can switch already to the second slide. Yeah, that's the privilege of the first speaker. Everything can be tested with me. So, yeah, what you see here is one of our projects, this APUS i5 cooperation project with Rolls-Royce. We are developing together with partners powertrains up to 1 megawatt and test them on a platform that is capable to do it. And yeah, this is one of the projects what you see here on the first page. Yeah, since we can focus on those powertrains, we set our goal, and the goal is to fly totally emission-free within the next 2 years. And we figured out some solutions from the whole spectrum, and our solution is hydrogen used by the fuel cell. And yeah, that's what we are doing in APUS. As I said, we are close to Berlin, east of Berlin, in Strausberg. Nowadays, 35 engineers there. We have a workshop to produce whole aircraft structures, whole airframe, and so we do design, certification until prototyping and flight test there. We are an EASA design organization, so we have some privileges during certification and making with the flights and also for the flight testing. That's some advantage. And yeah, some reference projects from the past, just to get a short overview. But I don't want to extend too much. I think there are some other speakers who want to present themselves too.
Hello. Yeah. Okay. Thank you very much, Philip. And I'm sure I at least have several more questions, which we can do later. And we have also the possibility, that's why we try to keep it as short as possible, that you get just an intro and then you can ask your own questions. So we'll have a microphone going around after the speakers are finished. Next speaker is from a company which we have on a very regular basis in our electric events, the company Rolls-Royce. And Pinyin, tell us what is the latest development in your department at Rolls-Royce.
Okay. So, hopefully you can hear me well. I don't have slides. Okay. So first of all, very nice to meet you here again after 2 years of pandemic. I've been a few words to myself. I've been a regular visitor of this show since 2012, and I'm very happy to be able to visit here again after 2 years of break. And here I'm very happy to meet my partners and also my colleagues and even my competitors here. So it's a very nice show, and I hope you are also enjoying. For personal information, I've studied in Aachen and worked for DLR for 5 years. And also Airbus for 5 years, and in 2017 I joined the Siemens Aircraft, and since then, since 2019, we are part of the Rolls-Royce Electrical community. And Rolls-Royce Electrical is our global distributed organization, and I'm very happy to say hello to our site lead from Norwegian in the public, and also from Hungary, Gabriel. Raise your hand. So I'm very happy to be here and to be able to discuss with all of you. So what we are doing in Rolls-Royce Electrical, we are developing complete electric propulsion system for advanced aerial mobility. So this includes urban air mobility, that is eVTOLs, and also commuter aircraft. Commuter aircraft is small passenger aircraft carrying 4 to up to 19 passengers, and will predominantly operated on short ranges below 200 nautical miles. We really believe this is a market segment that will enable the early market entry of electrification or electric propulsion technology. So I think that's all what I want to say. I'll pass it to the next one.
Okay, so if you pass the mic, and now we would have slides again. We will the slides which were on the screen already. Yeah, perfect. And perhaps if you want to see your slides, you can stand there and you can see slides. Otherwise you need a mirror.
I have a PPT.
Okay, that's good. No, but the PPT is now not on there. That's my mistake.
Okay, I was then. So thanks for the introduction, Willi. And thanks, of course, for the invitation and the great possibility to speak here this afternoon. And of course, good afternoon, everybody. It's great to see the eFlight community unite again after the COVID times here this year at the AERO 2022 in Friedrichshafen. Today, I am speaking on behalf of the HyFly consortium, which is is it this one? No, it's this one. That's the laser pointer. I think it's the green one in the middle. Oh, yeah. This is an R&D collaboration of 2 German technology firms, a German university and an Austrian-based flight test expert. And our team combines long-term expertise in the fields of aeronautical engineering, hydrogen fuel cell systems, as well as ground and flight testing and e-mobility, road and flight base in general.
The project is supported by the German Ministry of Economic Affairs and climate action within the CIM funding line. So that is to foster the innovative capacity of small and medium enterprises. My name is Kemke, and I specialize in aeronautical engineering, especially aircraft design and electric propulsion at AERO in Stuttgart, Germany. And I'm happy to present our project today. So what is HyFly about? As our brand name suggests, we focus on green hydrogen as a power source and are keen to bring this technology into general aviation, where it makes sense. And we believe it makes sense wherever range and endurance matter, and also our carbon footprint, of course. For example, to the private pilot, planning short, medium, and long-range cruising flights, cross-country flights, or to flight schools, or clubs in need for flight time instead of time on the ground for recharging. And hydrogen can be the key solution to many of those problems we face with sustainable flight today. However, a few requirements must be met for a hydrogen fuel cell system to deliver a genuine alternative to combustion engines or batteries. It must be affordable in terms of purchase and operating costs. It should be lightweight for enabling integration into very light aircraft, VLA, or even ultralights. And it should be easy to operate for new pilots or to simplify transition. And we ask ourselves the questions, can this be done without completely rethinking the airframe? Can it be done without using complex solutions such as liquid hydrogen or similar? Or without waiting for the magic formula, but instead using technology readily available today? We think so by sheer simplification and by exploiting synergies with other market segments. So here's an overview of our system. We store hydrogen in a spherical tank made from carbon fiber composites in an automated winding process. And the result is much lighter than everything we've seen so far. We use an off-the-shelf PM fuel cell stack that is soon to be mass-produced within the automotive industry and keeps the costs low. We operate the stack at approximately half of its rated power, which makes the surrounding devices, the periphery, much lighter and simpler, and it helps with efficiency as well. Regarding the EPU, there is no magic battery requirement, just a straightforward peak power source that will support takeoff and climb. It is recharged during cruising flight. It works with proven battery cells that are on the market today. Another question would be, where would all the hydrogen comes from? And our project partner, PS Hightech, bridges this gap and fills the missing link because they do not only focus on the usage of hydrogen in fuel cells, in mobile applications, or stationary applications, but they also focus on the production. Their vision is to have a decentralized, cost-effective, and green system using domestic renewables. Last but not least, our demonstrator. As you've probably seen in Hall B1, the flight design F2E has received a new look, and it's just the beginning. It's a proven airframe. It offers excellent performance and flying characteristic, and for our system, plenty of integration space. And thanks to flight design, during this year, the aircraft will be retrofitted with a fuel cell system and is going to be ready for testing soon. Stay tuned and don't miss the opportunity to meet flight design and the HyFly team at stand 101 in booth B1. In booth 101 in Hall B1, sorry. A prototype of the hydrogen tank is also on display.
Thanks, Kai. And I think it's interesting that some years ago we had a fuel cell already flying at the AERO a long time ago, but then it was quite calm around fuel cell activities in aviation. And now it's very nice because we have the HyFly, which is in hangar A7, and they are flying even with passengers now for proving of concept. And we have you coming up with a new solution. So because battery and energy density of battery is still the factor which keeps electric aviation from being on the market and flying. So if hydrogen can be one of the parts, it would be great. Our next speaker is Professor Lars Enghardt from a very new institute, as I hear. It's from DLR, the German Research Institute. So, and I'll let you introduce yourself and your institute.
Thank you very much. So, good evening, ladies and gentlemen. My name is Lars Enghardt, and I'm the acting head of the new DLR Institute, which was founded in the mid of the year 2020, right after the beginning of the pandemic, in Cottbus. So, electrified aero engines is our topic, is our mission. The mission is to the whole institute is in its research is dedicated on low emission future aircraft engines for commercial aviation, and we are aiming at more climate friendly and quiet air traffic of the future, which is as we can see here on this fair, for instance, based on hydrogen propulsion. We think this is part of, or will be part of, the propulsion future. So we think that we might be able to close gaps in the portfolio of German engine research. The whole thing is focused on propulsion systems with significantly, and this is one of the research topics, increased complexity and high requirements in terms of, for instance, in terms of intelligent control. So the future is brought with alternative aero propulsion, and the whole institute is scientifically orientated towards alternative, more extensively electrified aircraft engine. What we are planning to do is a holistic approach. You can see here our research profile, which starts off with the different components which will then be put together to form an architecture of novel propulsion systems. I don't want to go into detail of the text because other speakers are waiting to introduce themselves as well. Very important from our point of view, and I think most of you will agree on this, is aeronautical requirements. We really have to get this not only flying, but also being certified and licensed, and this is something which is a showstopper from our point of view. So aeronautical requirements is really a big issue in terms of electrified propulsion systems of the future. Last but not least, and the environmental impact, of course, that's one of the reasons why we are all doing this. We want to lower or even reduce the environmental impact of future propulsion systems. I already spoke about control. Control is a big issue. We don't want to overwhelm the pilot of the future with complicated systems, so the control system plays a very important role in the future. And of course, because there is, all these systems are pretty new, though there's really the lack of models. And what we are going to do is erect experimental facilities to test and then build on the test results new models which allow to design or even pre-design such systems to be facilitated or focused on specified future aircraft. So this is my last slide, just to give you an idea what we are going to do in Cottbus. There will be a new office building, of course, but what is really more important is that we are going to erect 4 large-scale experimental facilities which will allow us to test different kinds of electrified propulsion systems due to on the basis of different approaches, so electromagnetic stuff is tested. Then we have high voltage. We are going to do tests on components, and last but not least, we want to build up a realistic environment where we will test the whole propulsion system under conditions, flight conditions in about 30,000 meter flight. Sorry, 10,000 meter, 30,000 feet flight envelope. So last but not least, currently the institute is newly founded. So we have around 30 employees at the time being, but of course we are hiring. So in the end, in 5 years, we want to become 150. So if you're interested in working on research in future propulsion, electrified future propulsion systems, please visit our booth in Hall A7. We are on the common Brandenburg-Berlin booth, and you can find someone there to discuss what our research of the future will be and how you might contribute to this, to this approach. Thank you very much.
Thank you. And just this telephone which was ringing, it's not from us. It was left here on the stage. So if you see anybody who's looking for his cell phone, it was left on the stage here. We will keep it here. And I shut off the tone now, so it won't disturb us anymore. So, so we saw the research side on electric propulsion systems. Now we continue to motor, or say better, propulsion system design company, which is the company MGM COMPRO, and Jakob Henschel. He is head of marketing in this company. And so Jakob, if you can give us, perhaps saying something in behind, which he will say, they are doing a lot. They're doing a lot of different systems, VTOLs, non-VTOLs, and I think they were the company which had the most different aircraft with their system already flying over the last years here at AERO. So now your presentation is up, and stage is yours.
So thank you, Willi, for the longest presentation before I'm going to present. So welcome everybody here at AERO Friedrichshafen. It's a pleasure for me to see you face to face after some time, and I'm glad to present to you who we are, what we do, and where we're heading. So we at MGM COMPRO, as Willi already said, are the electric engineers who started basically 30 years ago with our own design of electronic speed controllers. But throughout the time, the story developed quite a lot, and right now we are designers, developers, and also manufacturers of the complex electric propulsion systems. Right now, beginning from a couple of kilowatts up to 400 kilowatts in the development projects I'm going to talk about a bit later. We have our own R&D facilities, as I said. We're 30 years on the market, even though our role developed throughout the time. We are a team of 50 professionals right now. We're based in the Czech Republic, Central Europe, not that far from here, and we export right now to more than 50 countries in the world. Here is basically our product portfolio. Not everything is for sure done just by us, but also in cooperation with our partners. But talking about the core components, electronic speed controllers, battery management system, battery packs, the overall design of the battery packs is done by us, so not just electrical engineers, but we have also our own mechanical department under one roof, which is a great, I would say, advantage we have right now. and we're heading right now towards our own range of the electric motors. There's a big project of building a new facilities going on, so the future is going to be, from my point, even more interesting as it was until now. So to briefly give you an overview what we do, what projects we are involved in, you can see that we are really the pioneers of the electric flying, as Willi already said. We have tens of projects already flying. Some of them are going into series production already. So it's much more about the certifications right now, not just flying demonstrators, but this is what we can talk about further in the discussion. So the main aim right now is going towards higher performance outputs, which is, let's say, above 150 kilowatts. And this is where our two current development projects are placed. Here's something about the commuter class aircraft electric powertrain, one of the projects, the biggest project we're working right now, all together with our partners, which should be finalized until 2025. And this should pave the way towards a, let's say, fully electric commuter class soon. Here are some of our reference projects. Maybe you're aware of them. These all are with our propulsion systems. Here are some of the references. So we work both with the big guys and also with the development startups, let's say, also with the research institutes, universities. So the range is quite wide. So that's all from my side. And in case you have any questions, just stop by at our booth and in Hall A7. You're welcome.
Thank you. Thank you, Jacob. And if you have questions, you also can stay here and ask the questions soon after Cam will give us his overview from United States, because we always try to bridge a little bit the gap, which especially now in Corona times has become even bigger between, as we couldn't travel so much anymore. So VFS is an organization where you will give us some more information about it. And yeah, let's see.
So I'm just waiting for the slide to get up there. So I'm representing the Vertical Flight Society. Some of you may know it as the American Helicopter Society. We were founded in 1943, and we're a community, really, of industry, academia, and government. We have 6,500 individual members and 180 corporate members, primarily working in the field of vertical flight. Now, of course, the industry has changed, and because we're a member-based society, a lot of what happens in our organization comes at the initiative of our members. We have 24 technical committees, but in 2014, we held our first eVTOL technical meeting in Washington with 100 people there, and they were the real visionaries on the eVTOL market. As the market has changed, we've evolved as well. And what we've seen is a continuum developing within the eVTOL world of personal and package to short haul. And as the range and the payload range gets extended, we have changes in the technology and the configuration of the aircraft. And then what we've seen more recently is changes in configuration from eVTOL to eSTOL with distributed electric propulsion, and then to conventional. And at the same time, to address the payload range issues, we've seen the choice of battery electric, hybrid electric, and hydrogen electric to address either the endurance or the payload range. And there's this continuum, and we as an organization, much like, I guess, Uber back in 2016 put out this idea of ecosystem, that it wasn't simply the distributed electric propulsion, but it was also the infrastructure. As an organization, because we're industry, academia, government, we've stretched in that respect as well. So one of the things that we did was in 2017, when the industry was still quite young, we started to track the programs. Our members were saying, what are all these things? They're traditional helicopter people to a certain extent. And when we put up the first eVTOL.news ledger of aircraft, we could only come up with about 8 at that time. I'm sure Willi had more, but to us in North America, and I'm a Canadian speaking on the behalf of a US-based organization, we could only come up with 8 concepts. This is where we are today in terms of the concepts, and on our website we have every one of these. Now, not all of them are real. There's from the silly to the serious, but it tells you how this segment has exploded. And behind each of these programs, of course, is a propulsion system as well. The other thing in terms of definition stretch that's taken place is that we've gone from urban air mobility to advanced air mobility. NASA has adopted that term, and what that encompasses is no longer just eVTOL, but eSTOL and eCTOL, as we call it, electric conventional, and it stretches into the regional air mobility. And as a regional airline guy who used to work for Bombardier, de Havilland, and Canadair, I see some analogies here where 20 years ago we were dealing with regional jets and turboprops, and what was the crossover point between those two different propulsion systems. We're in a similar era today where the propulsion system is changing and the market's evolving as well. And so these things share common architecture in that there's the batteries, the motors, and whatever. And in both cases, these are Part 23 certified aircraft. So even the certification category is stretching for both vertical flight and for fixed wing, where they're both under the same bucket. And from my hometown in Vancouver, we see this very clearly. We already have urban air mobility where 500,000 people don't go to the airport to fly. They fly in helicopters, they fly on seaplanes. And you can see the duplication of the routes, but the technology that people here on the table are going to be developing will also be filling those market requirements. And the last thing I mentioned is we're doing the Electric Aircraft Symposium as well. So that's the full stretch of the organization.
Oops. Thank you very much, Ken. And I know very well that you do these forums because we changed. I come to your forums, you speak at our forums, and I think like this we try also to bridge the around the world, because this is one thing which is really amazing inside the aviation. And now for you, if one of you wants to ask any questions, my colleague Sin has the microphone here. Just lift your hand and you can ask any questions. Until the first question will come, I will ask my question, which I have. Yes, so on the hydrogen, especially at APUS, I know you told me something which is not in your presentation here, but I was quite interested in this technology where you said, okay, you have also an additional thing you're working on, which is storing the hydrogen, because the storage of the hydrogen, this is one of the difficult issues, because if liquid, you have to cool it, and if you have it in a tank and you leave it there for 2 weeks, most of it or a lot of it is gone. So can you tell us a little bit more on this? I think it's kind of solid way of storing the energy which is in hydrogen, which could be used, for example, for the backup part of the energy which you have to supply, because all of us, as most of us are pilots, we know that if you fly an aircraft, you have to have a reserve. And if it's a commercial aircraft, you have to have a very defined, quite long reserve, considered how short the electric aircraft fly at the moment. So maybe you can tell us something about it.
Yes, what you're speaking about is the sodium, using sodium to store hydrogen, but first, I have to advertise, of course, our favorite solution, what we are using right now. This is to use simply pressurized hydrogen in our wings and use the very strong fuel tanks as the carrying wing structure. That's what you can visit when you go through this door directly on the corner on hall A7. So that's what we are doing. One big challenge is, of course, for the future to produce green hydrogen. Today we have only 0.1% of the needed green hydrogen, of the needed hydrogen is produced green. So we have a huge need to produce hydrogen. So we have to use all kinds of producing hydrogen what we can get. And one of those solutions is to use seawater by electrolysis and split the sodium from the chlor. And later, from chemistry, maybe you know still this process when you put sodium into water. It's a strong exotherm reaction, and the hydrogen comes out from there. So there are some advantages in this value chain of producing hydrogen in that way, and this should show only we are not focusing only on one solution for storing hydrogen. We are looking around.
Okay, thank you. Pinyin, a question: how does Rolls-Royce look onto hydrogen versus battery? One is long-term, one is short-term. How are you playing? I know you're mainly working on the commuter side of the aircraft, and we maybe expect that commuters will be the first larger aircraft which will fly, because until we have all the regulation for eVTOL, it may be taking a little bit longer. So yeah, what do you think on this way of storing the energy?
First of all, of course, we also notice the energy storage is one of the technological challenge for the electrification, and we well realize the battery has some limitation concerning the energy density. However, most of our customers and partners are still working at this stream, so we do have our battery programs supporting this trend. And also, I believe hydrogen will provide an option for the mid and long term, but for the short term, let's say towards the year 2024, 2025, this is still one of the most viable option for both for UAM and for commuter segment.
Thank you. The question to Kai would be, you're working on the hydrogen solution at AERO or HyFly. I think it's two companies, which HyFly is a project, and AERO is a company behind.
AERO is one of the companies behind. It's also AERO does the aircraft part. Mostly PS Hightech does the fuel cell part, and we also have the University of Applied Sciences Würzburg-Schweinfurt with us in the team, and they do the testing, all the lab and ground testing. And
do you have you mentioned the F2E is probably first project here you're gonna have there. Are there also, for example, VTOL projects where you think of using this kind of the technology, or is this more further out?
I think it's more further out, especially for our solution, because we try with a simple and small fuel cell stack, a small and compact system, just to get the thing into the air. And as we all know, VTOL uses a lot of energy. An aircraft does so as well, but only for takeoff and climb. And the power demand is much lower. So you've been speaking about 150 kilowatts, which you are targeting right now with the electric motors, with the EPUs. We stay around 60, 70, just for having the dimension for it.
Okay, I would have a question which is going still a little bit on the topic of hydrogen. Professor Enghardt, you have there is a DLR institute, or there are other DLR institutes which are working on fuel cell technology. are you collaborating? Would you also work on the fuel cell part, or are you just focused on the electric motor part with your new institute?
No, the new institute is dedicated to a holistic approach, and I would say that most of the institutes which are currently active or were currently active before this new institute was founded, they are looking on electric flying or electrified aero engines from a bottom-up approach, and we are looking more from a top-down approach, which means that these other institutes, most of them, they are looking on the development of the fuel cell technology as an energy source, and we are looking from the perspective of the whole aero engine, or even more important, the whole aircraft, and see whether the integration, how the integration takes place, how we get this new novel propulsion system into a specified into a specified system, and how these two components interact with each other. So is this, we have to specifically design a propulsion system, and of course the airplane around it, and then there's an interaction between both, and this is the integration task where we will spend a lot of research on, and we think that this is an optimization loop which takes time and development, of course.
Okay, thank you. Jakob, a question to you. Have you been involved, as I know you worked with very different projects in different countries, also in fuel cell projects, or let's say electric aircraft project where fuel cell were the power source already, or are your project up to now just basically working with batteries?
Yeah, we have to take it the same as Rolls-Royce said. We have to take it from the customer's perspective first, as SME, and there's no other way, to do it. So, majority of our projects is battery-based, lithium-ion, lithium polymers used the most, and regarding hydrogen, yeah, we see a great future in it, definitely. But from our point of view, there's no time to be wasted, from our point of view. Don't take it personal, we don't have that much governmental money to be spent, and we have to be backed by our own money. So that's why we are market driven, that's why we have customers, and that's why our projects are battery based. Even though it has a lot of disadvantages, which is obvious. Yeah.
Yeah, I think there are a lot of indications right now that governments around the world are going to put more money in all the thing around the hydrogen, all the chains, production, storage, and propulsion system for cars and all different other things. So maybe we'll see more in the coming up years. I would have a last question on hydrogen now to Ken. I know the VFS also had a panel, or I think it was a weekend of research on hydrogen. We all know ZeroAvia as one of the more famous players around there. Are there other companies working on concrete hydrogen fuel cell projects in aviation you're aware of?
Yeah, what VFS did was about a year ago, we formed a hydrogen council. That organization is now split in two, one focused on the OEMs and the vehicles, and a second group looking at airports and infrastructure as well. And we were holding monthly meetings, virtual meetings, of course, which actually were quite beneficial to grow the organization, up to maybe about 300 people. And it was at the end of March in Long Beach that VFS had a hybrid event, about 100 people on site and 30 people virtually, focused on hydrogen and aerospace. ZeroAvia, of course, had announced in late last year a number of different partnerships with de Havilland, with MHI, RJ, with Alaska Airlines. Universal Hydrogen is another company that's looking at retrofits. In both cases, they're looking at 19-seat to say 70-seat capacity regional airlines. There was very early on an eVTOL company out of Massachusetts that was looking at hydrogen, and I think maybe 4 years ago, Urban Aeronautics in Israel was talking about leapfrogging battery systems from turbines to going to hydrogen. What you're seeing, one of the reasons this is happening, the Biden administration announced $1 billion support to hydrogen infrastructure in the US as part of the stimulation, the $1 trillion budget. So in there was to surprise to some, largely focused on automotive, but there is an aviation component to that. Similarly, in Canada, there's a green aviation initiative in, particularly in Canada and Quebec, where there's funding going towards green aviation, and hydrogen is on the list there. So a lot of it's grassroots. I think that Europe's more advanced in terms of the thinking around sustainable aviation. I think if you talk to people in the US and Canada a couple of years ago, they say, what are you talking about? But it's definitely coming around, and they're looking to Europe in some ways for some of the leadership.
Okay, thank you. Next question would be on pure electric aviation again. Seeing that when we look at the vehicles, everybody talks about that one of the highest hurdle will be getting into certification, because it's not only like if you look here, and there is a big difference here. If you look at the left side at the B-Hold, which is ultralight aviation, on the right side we have certified aviation, where the aircraft look very similar, but there is a big difference in the cost. If you want to do a certified aircraft, it takes much longer. Now we're going to electrification. There has been shown several light projects, and now to Pinyin, the question: what about the where you are with the certification? Because we have seen over the last years the LSA ultralight project with an electric motor, which at that time was still Siemens Electrical. In the end, it was Rolls-Royce, like the flight design F2E, was flying with a motor under the two flags, first as Siemens, later as Rolls-Royce. Are you working on this path as well, or is it more that you say no? With these, the market for us will be more the larger aircraft, the commuter side.
Yes. First of all, currently our product development and effort are concentrated on two market segments. The first one is urban air mobility, that is eVTOLs, and the second one is commuter, because we believe the market penetration will start in this segment, and we haven't fully stopped the general aviation motor development. We still have a certification program running, but the main effort is concentrated in these two segments because we have detected more customer pull from there.
Okay, I think there is a question from the audience.
It's on battery technology. So one of the advantages, as I understand it, of conventional fossil fuel is it's not inherently combustible, it needs oxygen. So when we have battery technology, they can, as far as I understand, like burst into flames if there's a short circuit. So my question is, how big of an issue for all electric flying is this, or how do you deal with this? Because safety is one of, in my experience, sometimes the deciding factor of whether you can use a technology or not. So, question to anyone who's...
So maybe we can get the opinion of everybody, quick answer on this, or everybody would like to answer on it.
I think safety is one of the distinct advantage which electrification or electric propulsion system can provide. For example, if we design our electric propulsion system, we have multi-lane concept. That means in case of a single failure, we if it's a 4-lane architecture, you will only lose 25% of the achievable power, and which will still make your aircraft by far much more safer than a conventional combustion engine, because you probably don't have this separation of power delivered so conveniently. So that's my opinion.
From experience with automotive, we know that batteries, which are, I think, the main risk associated with electric propulsion, can be quite safe, and car fires related to driven kilometers are lower with batteries than are with conventional cars, and I think we can keep and even increase the level of safety in the aviation world.
Yeah, also from our perspective, definitely safety first, as always, but I see the biggest value added in the approach in how you prevent from the let's say dangerous events which might happen within the battery. It's about the sensors, it's about the battery management systems, how you collect and evaluate the data, how you react on the situations before something fails critically. And this is also our approach. And then there is a second thing, which is how to react if through all this something happens, some safety extinguishing systems and etc. etc. There's a lot of development going on, and also this is a knowledge mainly driven by automotive sector, and this is it, yeah. But the prevention should also be a big issue.
I'll just add that we're in an unusual sort of interim period where the existing regulations regarding motors and fuel systems don't accommodate electric motors and batteries. But the regulators, of course, are very focused on how to address that, whether it's through special conditions or writing the new rules. And I feel confident that in order to achieve certification, this will be addressed in the rules. We're just in this gray interim area where the rules have not yet been finalized.
Okay, thank you. Any other question at the moment here? No? Then I have a question. In the morning, we had in the discussion with the eVTOL manufacturer, we talked about the different approach of some saying we want to have a pilot on board. Others said we want to fly autonomous like Whisk AERO from the beginning. Now the question is, if everything is running fine, probably we don't need a pilot. But in our aviation, like we have it right now, even if it's an automated landing, automated flying Airbus, which is flying already quite a long while, normally the fallback, if something is going wrong, is always going to the pilot. Now, if you have an highly automated electric propulsion system on board, when you're designing this propulsion system, are you thinking of we still have a pilot who will solve the problem if there is a problem? Or would you go and say, no, it's all electronic and we have also to get the fallback as fast as possible into the automation that in the end the pilot's just watching. So perhaps Kai, if you can think, if in your system, do you think of a highly automated system or mainly something which would be like the aircraft here? You still need a pilot with a lot of experience.
Our system is designed for ease of use, of course, and it should work the controller should work in the background, meaning the aircraft should be flown like a conventional electric aircraft. So the fuel cell system would be controlled in the background. We have some safety features. What I believe should, especially for CS certification, should be implemented is just in case if the fuel cell system fails, like you always have a sufficient reserve, whatever it may be. I would suggest at least a go-around and a traffic pattern inside the battery if the fuel cell system fails, and otherwise the other way around.
Okay, thank you, Professor Enghardt. When you do your research or you plan your research there, are you mainly looking at the efficiency of the propulsion system, or would also things like this fallback, autonomous flight, or as much as possible autonomous propulsion system be a question of your research?
I think the first priority will be efficiency and environmental compatibility, and I would say, low emissions, of course. This is the first priority. The second will then be that the handling, so that safety and security is really the big issue. And after this, of course, if control works, we can look at autonomous flight. But as we are focusing on regional aircraft, I would say at the time being, we are looking at piloted systems. So that's the state of the art we are looking at. And from my point of view, if everything works and is certified, the next step will be to think about autonomous flight. But I'm not speaking about general aviation in this case.
That's clear. Pinyin, on this question, as Rolls-Royce, you're working with VTOL, and a lot of people in the discussion of the efficiency of VTOL, they say, okay, the end goal must be the autonomous because it gets the aircraft more efficient. If you fly VTOL, you fly passengers in a small aircraft where you have 4 seats, 3 seats. If you can get rid of the pilot, you get 1 more seat to sell, which makes a better business case. Is this discussion, or do you leave this discussion at the manufacturers and say, okay, we deliver you the propulsion system you want, and if you wanted to have it, also the fallback situations handled autonomously, we incorporate this?
So first of all, if you talk about business case, I think the autonomous flying, if there is a lack of certification basis and or the regulatory bodies, I don't think there is a business case insight for short term, that's for sure. So we deliver our product into, want to deliver into an existing market. So, and we want to, of course, help our customers and also the airframers to be able to deliver this kind of autonomous flying system. And the electric propulsion is inherently easier to control, and or the control, autonomous control is easier to implement. And so our contribution is in that in the first place. And once you have established rules for autonomous flight or establish regulations for that, and there is a product inside, of course, we will also deliver it into that.
Okay, thank you. There is one thing which I consider is quite interesting for the electric aviation in general, which is when systems will be ready for the market. Because if you look back 10 years, we have the eFlight Expo since more than 10 years. And 10 years ago, people were saying, yeah, in 3 years, we have our products on the market. We have the Pipistrel, which is an aircraft which is certified, which is selling. Apart from this, there is not much at the moment. We'll see more. We will have a fixed wing session where I think fixed wing trainer and fixed wing commuter session on Friday, where we perhaps see things which are closer to the market. But just from your point of view, when do you think the first Part 23 system will be fully certified in Part 23, electric propulsion system, and when we will see it on the market in, let's say, a 4-seater aircraft? And perhaps this question to you three, because you're all working on this kind of aircraft, like perhaps Phillip first, and then...
Yeah, of course, we are always very optimistic. I see here Axel Lange, when you started with hydrogen powertrain, maybe 15 years ago, when somebody asked you at that time when it will be certified, what would you reply? We always reply in 2 years. And this is the same in here. No, we really think so. Our aircraft the powertrains are running. We are working on that, and the goal is in 25 we want to have certification. Special conditions are there on that. At least when we don't talk about autonomous fly, only about the powertrain, there's a realistic path. Yeah.
Okay. Gee.
I think it's usual if you have a new technology, everybody probably know the hype curve of Gardner curve, that you expect high expectation and somewhere you have the valley of tears. But I think now somewhere you will also then reach the constant expectation where all the stakeholders come to similar conclusion where the system could be certified. So based on our knowledge and also publications, most of the eVTOL manufacturers aiming at entering to market by 2024-25, as Phillip said, and that's also our realistic view on that. We think it can be realistically expected for the year 2025 and 2026, and that's also our timeline.
Okay.
I agree with the opinion about 2025. I would also say because I've been looking at electric aircraft in the past 10 years and seen designs mature from small solutions to CS22 certified solution, and it's only the next step that a CS23 certification can be granted.
Okay, so maybe we continue there, and then because it's time to wrap up in a way. Ken, yeah.
In the vertical flight community, really, there's a couple things at play. First of all, the majority of the over 600 projects listed they're going for Part 23 certification as in a sense, a vertical flight aircraft under a fixed wing category. And there's some progress in terms of people like Joby and others in terms of a certification path. Very few are looking the STC route, but that also, I think, may be the sleeper, the one that actually gets to the market first. Tier 1 engineering is going to be flying in the next couple weeks. They're retrofitted the Robinson R44 of the Magni-X Magni 350 engine. Magni-X has the certification special conditions. They achieved those in November, so the mystery's gone out of a bit of the engine side. And because it's an STC, they're not certifying the whole aircraft. The challenge is the means of compliance of the system and coming to terms with that. But that might be the easiest certification path, the STC route, certainly when it comes to vertical flight.
Okay, thank you. I think it's time for me to wrap up a little bit. Just as additional information, as I had to rush you through the panels here, there are some more panels and some more detailed panels. For example, I think the DLR is together with BTU is on Saturday giving a longer presentation of their whole approach, which they do in COMPRO there. So if this is interesting of you, just look in the guide, the special guide of the AERO, where you have all the electric stuff. And I just say thank you to my panelists here talking to you. Thank you for you listening. I know I always see it like if it's getting to an hour or longer, especially on the show, people are fading off because they have other things to do. That's why I think we're gonna have a coffee now. And thank you for joining. And the next panel, which we have, is tomorrow, same time, 3 o'clock, on enablers for electric aviation and eVTOL, which are all the other subjects apart from the propulsion system, which are still on the plate and have to be fulfilled before the electric aircraft take off. Thank you very much.